Welcome to this explainer. Today we're taking a massive leap forward in how we actually think about the law, diving into modules 2 and 3 of the C-LEAD curriculum. For centuries, our profession has been completely locked into this static view of legal documents, right? Just words frozen on paper. But what happens when those words wake up? What if a contract stops being just a piece of paper and starts being an active, executing performance? Today, we're going to completely shift our mindset from static paper drafting to a highly dynamic computational runtime perspective. We're exploring how legal engineering isn't just some trendy buzzword, it's literally the foundation of the digital world we live in today. Okay, let's dive right into this because I want to validate something for you right off the bat. If you're a legal professional, a law student, or really just someone who understands contracts, you already possess the absolute hardest skill required for computer science. You have it. It's logical reasoning. As Kyle McLean Smith points out, you already excel at complex conditional logic. I mean, you map out if-then scenarios every single day. Literally, the only thing standing between you and engineering the automated law of tomorrow is just a lack of familiarity with programming, grammar, and syntax. That's it. You already have the architectural mind, you just need to learn a few new labels for the tools. So here's our roadmap for bridging that gap today. First, the roots of legal engineering. Second, Goldfarb and redlining the web. Third, Szabo and hard-coding legal consideration. Fourth, decoupling logic from assets. Fifth, mapping legal data primitives. And finally, the future of the profession. Section 1. The roots of legal engineering, building the digital world with legal logic. Now, if you feel like coding and computer science are somehow totally alien to the legal profession, prepare to drop your guard a bit. The historical precedent actually proves the exact opposite. The foundational architecture of our modern digital world wasn't just built in a vacuum by mathematicians. It was actually built by translating traditional jurisprudential legal drafting into information technology. And why does this matter? Well, because the core macroeconomic objective of legal engineering is efficiency. Whenever we write a contract, we're defining the performances, those obligations that human parties have to fulfill. By mechanizing and automating those legal performances, we drastically reduce societal transaction costs. We literally take the friction out of human agreements. That is the entire driving force behind turning static law into executable code. Section 2. Goldfarb and redlining the web, the legal origins of markup language, which kicks off our coverage of video 3.1. To really prove that legal thinking architected the digital world, we honestly don't have to look any further than the very fabric of the internet itself. Meet Charles Goldfarb, widely considered the grandfather of the internet. So how did he build the foundation of web pages? Well, he looked at traditional legal redline drafting. He took those exact jurisprudential techniques that we use to manage, track, and structure legal documents, and he digitized them to create GML, or generalized markup language. He essentially proved that legal syntax could be translated directly into a syntax that computers use to structure information. The journey here is super direct. Pre-1970s, we basically relied on static paper contracts and manual redlining. Then, in the 1970s, Goldfarb translated that exact legal engineering into digital redlining with GML. Fast forward to the 1990s, and that precise logic evolved into HTML, hypertext markup language. Seriously, every single time you open a web browser today, you're interacting with a language that owes its very existence to legal drafting principles. How wild is that? Section 3, Szabo and hard-coding legal consideration, the birth of smart contracts. And this covers the concepts from video 3.2. Okay, we've seen how legal structure gave us the web, but what about decentralized finance and blockchain? Enter Nick Szabo in the late 1990s and early 2000s. Szabo successfully translated the court tripartite elements of a traditional contract into programming language, but his absolute stroke of genius was looking at the deeply familiar legal concept of consideration, the exchange of value. By ensuring that consideration was literally hard-coded into the digital protocol, he created a system that automatically incentivized decentralized network validators. And boom, that is the birth of the smart contract, automating the legal concept of consideration to power trustless networks. Now, what's really interesting about this number is the sheer scale of what those two translations actually achieved. By applying jurisprudential techniques to IT, Goldfarb with markup language, and Szabo with smart contracts, legal engineering has arguably created over $20 trillion in global value. That's 20 trillion with a T. This isn't just theoretical stuff. It's literally the most lucrative translation of logic in human history. So, that begs the question, how do we translate legal logic into executing code?
If the legal pioneers of the past could translate their logic to build the internet and blockchain, how do you, right now, today, translate your legal logic into executing code? Let's pivot from the historical storytelling and break down the fast-paced, highly practical mechanics of computer science design.
Section 4. Decoupling logic from assets. The composer metaphor. This brings us to video 4.1. To really guide our minds into the foundational design of computer science, we have to distinguish between two concepts that lawyers often kind of blur together on paper. Think of a music composer. A composer doesn't play all the instruments at once, right? They design the stage, they orchestrate the verses, the looping choruses, and they write the sheet music completely beforehand. Once that design is locked in, they hand it to the orchestra, hit play, and then simply watch the performance execute from start to finish. This is exactly what a software runtime is. You do all the logical engineering up front, and then the code simply executes the performance. And this brilliantly illustrates the absolute necessity of physically separating the executing machinery from the material it processes. On one side, you have instructions. This is your logic, the rules of the contract, the machinery itself. On the other side, you have data. These are the assets, the specific names, the actual money being processed. In a traditional paper contract, these are just mashed together in a single paragraph. But in a computational runtime, the logic and the assets must be entirely decoupled. Section 5. Mapping legal data primitives. Translating the vocabulary. This covers the essential concepts from video 4.2. Now that we've decoupled the machinery from the material, let's learn the basic grammar of this new language by mapping traditional legal inputs to their data science equivalents. So the crucial point is that you already know all of this. We're just assigning new computational labels to your existing expertise. When you write a client's name or a text description, in code, that's simply called a string. When you write down monetary values, ages, or dates, in code, that's a number. And when you draft a condition that must be met, like a yes or no, an if-then scenario, that's called a Boolean, which is just strict true or false logic. Strings, numbers, and Booleans. That is your core data primitive vocabulary. Now, why do these specific labels even matter? Well, because code actively protects you. When you enter a name into a static Google Sheet, it just kind of sits there. But in an active JavaScript runtime, when you assign a specific data primitive to a variable, like saying purchase price absolutely must be a number, the code actively performs strict type checking. If someone tries to enter a text string where a number should be, the runtime just rejects it right then and there. Enforcing these strict typing domains acts as an automatic safety guardrail, essentially preventing massive legal logic errors while your contract is actively running. Section 6. The future of the profession. The macroevolution of legal careers. Let's zoom out to wrap up this explainer. The legal profession perfectly mirrors the evolution of transportation. Traditional, static analog lawyering, that's the horse and buggy. What we are moving into right now with legal engineering is mechanized law, kind of like the very first cars. It introduces hyperspeed, but definitely requires new regulatory guardrails. But the ultimate destination here? Automated law. Autonomous, self-executing systems. We're talking the Waymo of legal contracts. The deliverables of our profession have evolved from static paper into active software, and you already have the logical mind to architect it. So I leave you with this provocative final thought. Will you remain a traditional analog lawyer, or will you adopt programming syntax, embrace computational legalese, and actually engineer the automated law of tomorrow? The choice and the future is completely yours. Thanks for exploring with us today.